put it on video. That's gonna go on YouTube. Go on. Them cursing in Spanish. That's what I had there was to run boots. I was standing at this booth for hangman, and he had like this ball. And you had to guess the word, but there was only one teacher there. So we'll figure out to help them. And then I took one ticket, and then I got this, and then I went to class as well. And then the three of us were just like, okay, what word is it? Okay, this one, okay, here's the word. Write down. And then so many guys were like so noisy. They moved to the other side and they helped us freedom on that side. The teacher could handle them on that side. This is so chaotic. Not in charge. Huh? No, she is. She just didn't ask us for
So let's carry on with our discussion from yesterday. Okay. Right, so we finished discussing the meaning of the term absorption and desorption. Okay, so absorption means yesterday we ended in a rush. So maybe you can add some, we just started, okay. So you can add a few points back, okay. So normally, so you can put down, normally, this car I'm going on the left, okay, shows what happens when you are running on unleaded petrol, okay. So unleaded petrol means there's no lead inside the petrol. So when we have the so this is if it is running unleaded petrol. Okay, so this is unleaded petrol. Yeah, so there's no lead in the engine. Okay, and that means there will not be any poison, okay, present. Okay, so note that lead we say it's a poison because it can coat the surface of the catalyst. So there will not be any absorption happening. So without absorption, the bonds cannot be weakened. Okay, so you can put down in here what does absorption really do. Okay, so absorption can so here can weaken the bonds in the reactants. So it can weaken the bonds in the reactants. So it's to facilitate reaction between them. Yeah, and this would facilitate the reaction between the reactants. So between the reactants. So without absorption, like a reaction would be happening with difficulty. Okay. So what does the lead really do? Okay. So does anyone happen to have a spare tip in? Okay. No spare tip. Never mind. I think it has some bad contacts. Okay. I will try to just keep on writing with this, but it's not like really working properly. Okay. Anyway, so you have catalytic poison. Do you have an extra tip? No. Okay.
You can use it all over.
Yeah, can I borrow? Can you make sure you remind me like that?
Boy, you take back your Apple Pen later.
Yeah. So can you just put your maybe? Do you need to drop notes with your pencil? Yeah. Let me borrow this. Remind me. Yeah. All of you remind me. Yeah, please. Okay. So and facilitate reaction between the reactants. So when you have okay. I think it could well be the
Just do the whole thing.
Yeah, let me just borrow your pen. Okay. I think it's not possible that I use that pen.
Yeah, it's different.
No, you still can.
This one still.
No, you still can.
Yeah, it's different.
It's another
It's
one.
wrong.
No, sir, you just plug in.
Like that. Let me just switch back first. Sorry. Yeah, turn this on. Can I borrow your camera? Just please. Yeah, data you
Record.
data from here. Okay, just 1 second. So we have, okay, that's much better, thank you. Okay. So you have the catalytic poison. So catalytic poison is lead. So this is present in lead petrol. Okay, so lead petrol. And why was lead added to petrol, you may ask? Okay, so lead was added to petrol to make it burn more smoothly. So to make it burn more smoothly. But eventually people realize that, well, lead petrol, while it will make petrol burn more smoothly, it doesn't go well with the catalytic converter. Okay, so here you can write up, but the catalytic converter doesn't go well. You see, catalytic converter solves another problem. So while adding lead to petrol solves the problem of lead not being able to burn properly, we also need catalytic converter to be working at the same time. So, but catalytic converter can be poisoned. Okay, so by lead particles, as described on top here. So you see lead, it will just form a coating on, you know, the surface of the catalyst, which prevents the adsorption from happening. So on the left, you can say normal adsorption can occur. So normal adsorption can occur when there is no lead in the petrol, but when you have lead in petrol, so this is what happens when you use lead in petrol. The petrol now burns more smoothly, but unfortunately, there will not be any adsorption anymore. Okay, so no adsorption. Therefore, you need to replace the catalyst. Okay, you need to replace the platinum catalyst in the catalytic converter just to solve this problem. This is irreversible. Okay, so poisoning. Just one more point before we move on. So poisoning of the catalyst is irreversible. Okay, so it is irreversible. So that will mean that the catalyst has to be replaced. And that adds to the cost. Okay, so it has to be replaced. So far we have been focusing on just the chemical catalyst. But you see, in chemistry, we don't just study chemical catalysts, we also study biological catalysts. And biological catalysts are what we call enzymes, right? So on the opposite side, we still have some space here, you can put down types of catalysts. So we have two types of catalysts. They are the chemical catalysts. What we have been learning so far, they are all almost always elements, compounds, or ions of transition metals. So these are chemical catalysts. They are elements, ions, compounds of transition metal, usually. Okay, so usually, but not always. You see, corn sulfuric acid is a catalyst. For which reaction again? Corn sulfuric acid. We mentioned this yesterday. Corn sulfuric acid is a catalyst for esterification. Remember, corn sulfuric acid doesn't have any transition metal, so this is why I put usually. Okay, so they are usually elements, ions, or compounds of transition metals. So put down these examples. So it seems like some of you have forgotten about this already. So you have elements, which could be iron in Haber process. So iron in Haber process, N2 plus H2 becoming NH3. You have compounds such as vanadium 5 oxide in the contact process. So this is a compound, you see. It has vanadium bonded to oxygen. Finally, you can also have ions, okay, like Fe3 plus in the reaction between I minus and S2O2 minus. So this is, or I should say these are examples of chemical catalysts. The second type of catalyst, we call them biological catalysts. They are also known as enzymes. Okay, enzymes. So there are some examples. We have cymase. So cymase is an enzyme found in yeast. Okay, there's also maltase. It's usually easier to understand enzymes because enzymes are usually are named after the substance they digest. Okay, so for example, maltase digests maltose, amylase digests amylose. Okay, but yeah, there are too many. Okay, and we're not doing biology. So just know that different enzymes digest different things. Okay, so enzymes, they are proteins that can speed up biochemical reactions in living things. Okay, so biochemical reaction in living things. And we'll just look at one such example or examples of a few examples of biological catalysts. Okay, it is in the fermentation of glucose. Okay, so those of you who do biology will know that respiration has there are two different types. There's aerobic and there's anaerobic respiration, right? Yeah, aerobic means there is oxygen, and aerobic means there is no oxygen. And if you have done this in biology, then you can already remember. You should already remember these equations. For example, starch. When you add water to it, it will break down into maltose. And maltose, when you use the enzyme maltase on it, so this is diastase. So this enzyme that would turn starch into maltose. Okay, by adding water to it, we call it diastase. So just like you will write equations like this for chemical catalysts, you can also write equations like this for biological catalysts. Okay, remember this equation we learned a while ago? Hydrogen peroxide can be broken down into which two substances? Oxygen and water, using the help of which catalyst? It's a black solid.
MnO2.
Yes, MnO2. Okay, so just like you will write the catalyst on top of the reaction arrow, you will also write the name of the catalyst on top of the reaction arrow here. It's just that these are not, like a reaction that happens in a beaker. Instead, these are reactions that happens inside your body. So we call these biochemical reactions. Okay, yeah, or maybe not in your body, but in other living things. Okay, so you have H2O and O2. And these reactions, they will still work when we take them outside the living organism, as long as we put in the biological catalyst. So we have maltose being broken down by maltase into glucose. And finally, glucose will undergo a fermentation process, okay, with the help of another enzyme, cymase, and it will become ethanol and carbon dioxide. So I just need you to remember the formula of ethanol because this is the the only thing that makes sense to you. Okay, if you also do chemistry, what's the formula of ethanol? And what's the general formula of alcohol? C2H5 OH. Yes. Okay. And the answer to the question, general formula of alcohol should be CnH2n plus 1 OH, right? So this is the thing that I need you to know the formula of. For the other ones, if you really can't remember, it's fine. But I'm putting it down anyway. So C6H12O6 for glucose. Yeah, so this should sound familiar if you do biology. And you have C12H22O11 for maltose. And you have C6H11O5, okay, C6H10O5, and to be the formula of starch. Okay, so when starch breaks down, it becomes maltose. Think of starch as like a chain of hexagons. These hexagons are glucose units. When you add water to this chain of glucose unit, you will be able to cut it like a 2 at a time to form these small things called maltose. Maltose means 2 hexagon units combined. And when you add maltase to it, to maltose, these double units, they will be broken down into finally single units. this is the smallest it can get. And finally, the glucose, the single glucose unit here. Under the action of cyanase, it will be turned into ethanol and carbon dioxide. Okay, so this is how beer is produced, okay, and other types of alcoholic beverages. So you may know other types of alcoholic beverages, like wine, right, like vodka, okay? Yeah, so all these different types of alcoholic beverages, they are made by this reaction, okay? So the first reaction and the second reaction, where do they happen? They happen in barley seeds, okay? So when you brew wine, what do you need? You need barley, okay, or beer. When you brew beer, you need barley. So these reactions happens in barley, okay? So barley, like those grains, okay? And you will need to add also yeast into barley before they can be turned into beer.
Yeah.
Yeah. Okay. Have you attended those wine brewing workshop?
We're not old enough, sir.
Well, there are some fermented products that are not very high in alcoholic content, like kombucha. Have you heard of kombucha? No.
What is
How is that possible? Kombucha.
What is that?
What's called?
It's like
I think it's
you
Korean
add
and Chinese combined. It is kombucha
Oh.
means this is an actual English term. Okay, you can find.
I think I might
Yeah,
have had
it
it.
is a fermented like an alcoholic drink.
It's
Yeah,
called
that
alcoholic.
have some health boosting property. Okay. Yeah, so this is I think similar in alcoholic content to maybe Jolly Shandy or maybe a little bit higher. Yeah, I think Jolly Shandy is fine, right, for all you. Yeah, so these are alcoholic drinks. Okay. So all alcoholic drinks, they can be made. Let me put this on the next page. So by the fermentation process. Okay, so fermentation is a process, okay, of turning glucose into ethanol. Yeah, with the help of yeast. Okay, so into ethanol. You must remember the organism yeast. Yeast is a type of fungus. Okay, so process of turning glucose into ethanol using
It's fine. They look like.
using the enzyme cyanase in yeast. Okay, so cyanase is a key term. Okay, so present in yeast. So yeast are these single cell fungal organisms. When you look inside, you will find a lot of of those enzymes. Okay, cyanase. So now you just have to add yeast into a sample of ethanol. So this is ethanol, C2H5OH. Into a sample of glucose. Sorry. So glucose. This is C6H12O6. So when you add the yeast into the glucose, they will start the fermentation reaction. So the fermentation reaction is C6H12O6 becomes 2C2H5OH plus 2CO2. I've already balanced this equation for you. Okay, so don't worry. You just have to focus on the name of the reactant and the product. So can you see that glucose C6H12O6 is converted into ethanol, right? Yeah, but this reaction can only produce a very low concentration ethanol solution. Does anyone know why? Well, I can think of two questions that they will probably ask you in exam. Is that number one, the solution turns cloudy over time. Yeah, it went from clear, so this was a clear solution. It then becomes cloudy. So the first question that they will probably ask you is, explain why the solution turned cloudy as fermentation occurs. This reaction, by the way, we call it fermentation. Okay, why? Any idea?
CO2.
No, not because of CO2. CO2 is colorless gas. So biology students may know. Is that the yeast multiply? Yeast is a living organism. It is not dead. It is not a chemical. It is living. Okay, so when it double in the concentration in the population, then it will make it cloud even more and more cloudy. Okay, yeah. So I saw this in a chemistry paper. Okay, not necessarily in DSE, but they can totally adapt this. Okay, so explain why. This is to show that it is not dead, it is living. Okay, so explain why the solution turns cloudy over time. So the short answer to this is that the yeast multiplied. It increased in population. Okay, and the second question, more chemistry related now, is why won't the ethanol concentration should pass 15%? In fact, if I were to plot the concentration of ethanol, how it changes over time, you will see a graph looking like this. This is the ethanol content in percent, and this is time. The graph will look like this, so it will rise up and then comes to an abrupt end. Anyone know why?
Glucose is used up.
No. We assume that there is enough glucose to sustain a very large population of yeast. Okay, that's not the reason. But I try.
Ethanol what? Yeah, why the concentration stays?
Sorry?
It is on purpose to bring it 50%.
No. It's that you will never get past 15%.
Never get
Never get past 15%. No matter how much yeast, how much glucose you add.
Not enough.
Yeah, actually, this is also a hybrid of chem and biology. Okay, is that the ethanol produced is toxic. You know, if you drink too much ethanol, you will die.
Yes.
Same for the yeast. Okay? But then yeast is kind of weird in that it produces something that would eventually kill itself. Okay, ethanol is toxic also to yeast. So when it accumulates to a high enough concentration, it will kill all the yeast.
Oh.
So you produce something that kills yourself.
Wow.
Yeah, how silly. Okay, this yeast. Okay, so you can put down why won't the ethanol concentration pass 15%? Because ethanol is toxic. Don't say words like harmful, dangerous. Those words don't mean anything in chemistry. Okay, you use toxic. Okay, just like CO is toxic, or you can say poisonous. Okay, so ethanol is toxic to yeast. So as ethanol concentration reaches 15%, it kills all the yeast. So it kills all the yeast. So the reaction comes to an abrupt end. You see, it's not even smooth, this curve. This is not even a curve. You know, this is what a curve looks like normally, right? This reaction comes to an abrupt end. Okay, it levels off like abruptly. Okay, so it kills all the yeast, and this stops the reaction abruptly. So, but does that mean that we can never get alcoholic drinks with alcohol by volume larger than 50%? You know, when you go to the supermarket, you find a lot of different alcoholic drinks, like vodka. They can easily reach 50 or 40 something percent alcohol, right? So how are they made? Yeah, they are made by distilling the mixture. So can you put this down in here? This mixture will at most have 15% ethanol. But by carrying out distillation, so you know distillation can help concentrate the ethanol, okay, to higher concentration. So you just have to remember this technique. So by distillation, by fractional distillation, yeah, we need fractional distillation because in this solution you don't just have ethanol. You have another very similar boiling point substance, water. So normal, simple distillation will not work. You need to use fractional distillation. You can concentrate the alcohol content, okay, to about 15%. Yeah, so if you don't do anything about it, okay, you will get what we call beer. So beer has low enough ethanol concentration. Well, you should not drink it still, okay, so because 50% is still a lot, okay. But if you want to make the alcohol concentration go higher, like you want to make things like vodka, okay, yeah, like vodka, whiskey, or like rum, those stronger type of alcohol. Yeah, you know these type of alcohol, they are strong enough that you can use it to sterilize your wounds. you know doctors when before they do a medical procedure they need to wipe alcohol over your body, right, before they do procedure to kill the germs. If you sometimes when you watch movie you may think that they are actually joking. When they pour wine or vodka or whiskey on a patient's body, that's because they don't have real medical grade ethanol around. In that case, vodka and whiskey will suffice because they are also very high in ethanol concentration. They can kill germs. Okay? Yeah, and eventually if you drink enough, it kills you as well. Okay? So that's fermentation. Okay? So any question you want to ask me about this process here? So okay, here, yes.
For the breakdown of the glucose, when the catalyst, we need to put the sign.
Yes, you need to remember the name.
Yeast.
Yeast is not the name of the enzyme. Yeah, okay, so you have to narrow it down to that specific enzyme. Yeah, this specific enzyme. So this is why the word synase is important. You can't just say yeast. Okay, yeast is just a living organism. You wouldn't say a person is responsible for this reaction, right? No, it's more like something inside this living organism called synase is responsible for this reaction. This is the keyword synase. Okay, these two enzymes, they're not as important, but this reaction is very important. This reaction we call it fermentation. Okay, of glucose. Yeah, if you like, you can add another word in here, to ethanol. And this is how alcoholic drinks are made. Okay? Yeah, and here we have a very, very quick summary here. A lot of different starchy plants. So for example, potato, for example, grapes, for example, barley. Okay, all these are plant examples. Okay, they are all rich in starch. Okay, so when you use the enzyme diastase on them, they will be broken down into maltose. Okay, so maybe first of all you collect the starch from them, and then you use the enzyme diastase. So diastase to break down the starch into maltose. Yeah, not need to remember the formula of starch and maltose. Just know that we are interested in the final product and also the final reaction here. So glucose will ultimately be formed, and the glucose can then be turned into ethanol and carbon dioxide through the fermentation process. Yeah, and this is carried out by the enzyme synase. Yeah, into ethanol. Yeah, and carbon dioxide. So normally this solution will only be 15% concentrated. Okay, if you want to boost the concentration, you may want to carry out fractional distillation to further increase the concentration from 15% to higher. Like say you want to make vodka or whiskey, I don't know how much alcohol there are in those things, I didn't maybe say anyway. So you have larger than 15% alcohol, okay, out of these things. So if you just want to get beer, the process can stop here. If you want to make vodka or whiskey, you will have to carry out also fractional distillation. Yeah, these are stronger alcohol. Do you get it?
Yes.
Okay, yeah, and what must you know? The name of the enzyme synase and the formula of glucose as well as that of ethanol. Okay, yeah, you should know ethanol very well. Okay, so next up, we need to look at the industrial process. So then this wraps up the catalyst chapter, the catalysis chapter. So what did we learn in this chapter? We learned a few properties of catalysts. For example, they are needed in small amounts. For example, they are very specific. For example, iron only catalyzes Haber process. Iron cannot catalyze contact process. This is what specific means. You need one catalyst for one reaction. You also learn that they work by lowering the activation energy, by providing an alternate pathway with a lower activation energy. So that's what we learn in this catalysis chapter. Okay? Right. So then we'll turn to the next chapter. It's the making of fertilizer. Okay? But first, we need to look at Haber process. And also why we need fertilizer in the first place.
What is the name of this chapter?
It's chapter 53. I forgot the name. Let me just go back here. But 53 is the, oh, sorry, 54. So chapter 54 is called industrial processes. Chapter 53 is catalysis and industrial processes. And now it's just called industrial processes, okay? So, Haber process. Oh, first of all, we need to look at fertilizers. Why are they so important to life? Well, fertilizers, we sometimes call them NPK fertilizers. After the type of elements found inside fertilizer. What are they? Nitrogen, phosphorus, potassium. Yeah, you know why I ask this question, because at this point a lot of students still think that P stands for potassium. No, okay. So P is phosphorus, okay. And fertilizers are needed by plants, okay. And many different ions can provide these elements. So N can be provided by nitrates or ammonium ion. So P can be provided by phosphate ions, and K can be provided by K+. So what are fertilizers then? Fertilizers are chemicals that contain one or more of these ions, okay? So fertilizers are chemicals, mixture of one or more chemicals that contain these ions. So that contain these ions, okay? And they help to make the plant grow more healthily, okay? So these are ions, okay? So they can make plants grow healthily. So why do we need fertilizer in modern days when we don't need any in the past? You know, in dinosaurs' time, we were not even here, but seems like plants can still thrive, right? Why is that only in modern time that we need fertilizer? Because, sorry? Oh no, it's not because of pollution. But because, you know, we do something called industrial farming, right? You see, back in the days of dinosaurs, do we remove plants from the field as often? No, we give enough time to the plants so that they will decay and return the nutrient back to soil. But in modern time, this is not possible. Yeah, so they make plant grow more healthily, okay, and they, most importantly, replenish, okay, the lost nutrients from soil, okay. So the lost nutrient from soil due to intensive farming. So you know, these days we don't just farm animals, okay, we'll also farm a lot of crops. And if we keep extracting the nutrients from the soil without replacing it, the soil will become less and less fertile. So this is what it looks like. Yeah, due to intensive farming. Okay, so replenish the lost. Replenish means replace. Yeah, the lost nutrients from soil due to intensive farming. So let's take a look at the level of nutrients in soil over time. So level of nutrients in soil, and the x-axis shows time, and on top those are topsoil. Okay, so you see soil here. So at first you are just growing one plant in here. Okay, so the nutrient level will remain pretty high, but as you plant more and more crops, yeah, so the nutrient content, it will start falling. Yeah, and to make things worse, you will remove the plant from the soil just to sell it in the market. So those nutrients that the plant has drawn from the soil, they are gone forever, gone to the supermarket. Okay, so the nutrient level in soil will drop to a very, very low level. In this case, we say we have made the soil infertile. Okay, so the soil is no longer fertile. They can no longer support the plant growth. So to replenish that, we can add fertilizer. So we can add fertilizer back into the soil. Okay, so that's how we make the soil fertile again. So you can see in here fertile, and so this is also fertile. And what did we do in this process? We have added fertilizer. Okay, so application of fertilizer. So from time to time we need to do this. especially if you own a farm, then you need to do this, okay, from time to time. And so how do we make fertilizer then? Back to the chemistry, focus. It's by Haber process first, okay? So fertilizers can be made by neutralizing ammonia with different types of acid. So the first key point. Fertilizers, okay, usually contain ammonium compound. What's the difference between ammonia and ammonium? Which one is NH3, which one is NH4 plus? Ammonium is NH4 plus. Ammonia is NH3, okay? So ammonium compounds therefore translate to compounds with NH4 plus ion, okay? So to name but a few, can you try to, all of you, can you try to name these compounds or maybe tell me the formula? What is ammonium chloride? I need the formula.
NH4Cl.
NH4Cl. What about ammonium nitrate?
NH4N3.
Yes. What about ammonium sulfate?
NH4
Yes. Okay, very clear. Okay, so that means you know the charge of nitrate, sulfate to be 1 minus and 2 minus respectively. You have NH4Cl, which is made by you joining NH4 plus and Cl minus. What about nitrate? What is the formula of nitrate? NO3 minus, yes, NO3 minus. So you see, because the charge is 1 and 1, 1 and 1 here, when you do the crisscross rule, use the crisscross rule here, you don't see any number on the outside. You see just 1 in here because of that. And with ammonium sulfate, it's a little bit different. So just be careful when you see ammonium sulfate, because it's actually NH4 SO4. The 2 resulting from the charge of sulfate. So if you don't know the charge of sulfate, well, that's bad, okay, because you might guess the formula wrong, okay? So fertilizer usually contain ammonium compounds, okay, which can be made by neutralizing. Yeah, so these can be made by neutralizing ammonia by acids. So therefore, ammonia is a good start for making ammonium compounds, which are fertilizers. So ammonia is what you can use to make fertilizers. So to put it simply, you have ammonia becoming, so after being neutralized by acid, it will become ammonium compounds, which are fertilizers. So fertilizers. Okay, so maybe just put that a placeholder first, okay? So in here, look at Haber process. We actually have discussed Haber process some time ago when we look at equilibrium, right? Do you remember? Yep. Equilibrium. So Haber process is nitrogen plus hydrogen becoming ammonia. The mole ratio is 1 to 3 to 2. And the conditions, does anyone remember the condition? Fe catalyst, yes. 450 yeah, 450 degrees C and 280 A. So remember, these are one conditions. Conditions include 3 things: whether a catalyst is present, what temperature and what pressure is needed. And also, you should know that it is exothermic. You don't need to remember the number. I can't remember the number either, but you have to know that this is exothermic. Okay. And in the next lesson, we will look at how the nitrogen and hydrogen, they can be obtained, okay, for use in this reaction. Okay, so let me give you this is so any questions so far?